Hi, in this video I'm gonna go over two things with you guys. The first is called the position vectors, and the second one is called the resultant vectors. The concepts of these two types of vectors are relatively easy, so let's get started. Position vectors are the vectors from the origin to a point. So let's say today, if I have my x and y axis here, again this is in the 2D scenario, right? So I have my x and y axis, and let's say I have a point here, and the point, say it's at -2, and this is 5. So the point, and this is point A, right? It's at -2, 5. Then the position vector of OA, my O is the origin. No, we call this the O, right? Normally we give the point at the origin O to represent the origin. So the position vector of OA is -2, 5. This is in the column vector form, or if I use the unit vector form, it will be -2i plus 5j. Okay, so if I have a position vector in 3D, then I'm going to pause the video, and when I come back, you guys will see the 3D axis, and we'll do some drawings on it. Okay. All right, welcome back. So just keep in mind that position vectors are basically vectors from the origin to a point. So here, let's look at a 3D scenario. So I've created this XYZ axis, and I've drawn a box to kind of help me out to figure out the points on the box, sort of on the vertices of this box here. So I have a point B, right? I have a point B, which is, I hope you guys are now pretty comfortable with coming up with the coordinates in 3D. So my point B would have, in terms of my x-axis, it is 2. The y coordinate is 3. And my z is -4 because I'm going inside, so my z has a -4. So those are the coordinates of my point B, right? So we're talking about 3D, and if you're still not sure how did I come up with these coordinates, please do come and see me, and I'll go over it with you guys. However, since we're talking about position vector, what is the position vector of OB, right? Position vector of OB would be from point O, this is the origin, to the point B, right? So we are sort of going to the right, and then we are going up, and then we are going inside, right? So to get from one corner to sort of the opposite corner, right? Okay, so the position vector of OB would be 2, 3, -4 in terms of column vector, right? Or in terms of unit vector, that would be 2i plus 3j minus 4k. All right, so I hope you guys, it's pretty easy. The position vector, they're very easy to find, and later on we'll find them very useful. Okay, so let's move on to our next section, which is resultant vectors. All right, so for the definition of resultant vectors, they are pretty straightforward. It is the vector, the final vector, formed by combining other vectors. Okay, so remember that when we first talked about vectors, I mentioned to you guys that vectors only care about where I'm starting and where do I end at, right? It doesn't matter if how the path is like. as long as I'm starting from point A and I end at point B, then all of these three different paths would be the same vector. Okay, so resultant vectors, they will be very handy later on, so we need to make sure how to find them. And lucky for us, they are pretty easy to find. So for example, let's start with 2D again. Okay, so I'm gonna make my X and Y axis. Alright, so let's say today I have a point here, this is my A, and I have a point here, this is my B, right? And I want to get from point A to point B. Okay. So this is the concept, right? The concept of resultant vector is this: I want to get from point A to point B. So what I can do is get from point A to my origin first, right? This is my point A to origin, which is my AO. And then from my origin, I can just use the position vector of my B, so that will bring me from point O to point B. And this whole thing will give me what I wanted, vector of AB. Alright, so this is sort of the concept of resultant vectors. Right now, this is a 2D scenario, so you might think that this is something that's easy, but how is it useful, right? When we talk about 3D scenario, then everything becomes a lot more complicated. So, but the concept stays the same, right? So this, by adding, so we're trying, just let's get back to this example. We're trying to get from point A to point B. So it doesn't matter what the path is. So I'm going to take from point A, go back to my origin, and then I'm going to go from my origin to my point B. That will give me the same vector as this blue vector there. They're the same. Okay. So let's look at an example. So if I have 2 points, my A is at -3, 2, and 0. My B is at -4, 7, and 5. So as you can see, right now we have 3D. We have a scenario of 3D, right? And of course, we're not always going to put the points down on the XYZ axis. That will take us forever. So we need to use our knowledge of resultant vectors to find the vector of AB. Okay, to find it without drawing the XYZ axis. So my vector of AB is equal to my vector of AO. So I'm going to travel from my point A back to my origin, and then from my origin I'm going to get to my point B. My vector of AO is basically the negative vector of my position vector, right? OA. Plus my OB would be -4, 7, and 5. Right? So negative of OA, my OA is just my position vector of A. So that's -3, 2, and 0. Don't forget the negative in the front. Plus -4, 7, and 5. And that will give me, so I have negative, that becomes 3. Negative goes in, that becomes -2, and then the 0 is still there. Plus -4, 7, and 5. My final answer, my vector of AB is equal to 3 plus -4, that gives me -1. -2 plus 7, that gives me 5. And 0 plus 5, that gives me 5. That's it. So as you can see, just by applying the resultant, just by applying our knowledge on resultant vectors, without drawing, we can still find the vector. Okay? Let's look at another example. Let's say my vector xy, so now this is on random vector, is 2, 1, and 3. And let's say my vector xz is 0, -10, -1. Now they want us to find vector yz and find vector zy. Okay, now let's try this. So my vector yz is equal to my vector yx plus my vector xz, right? Right now they've given us xy, and therefore my vector yx is just the opposite of my vector xy, correct? This is the opposite direction, plus the vector of xz. So now I can just put it in, substitute the vectors given to us, plus 0, -10, -1. So my final results will be -2, and then -1 minus 10, that's -12, -11, -3 minus 1, that's -4. This is my vector of yz. Okay? Now for part B, they want us to find the vector of zy. So I could do this the long way, which is to do vector of zx and then plus my vector of xy, right? I could do that. Or I can just say my vector of zy is the negative of my vector of yz, right? This is so much faster because I have my vector of yz from part A. So I don't really have to do the long method, right? I don't really have to do this part. Let me change the color. This will give me the right answer, but that's a long way, right? Instead, we should use this. Okay? So now let's get back to this. So my vector of zy is just a negative of -2, -11, and 4, which is 2, 11, and -4. That's it. If you want, you can try to do this on your own. Try that and see if you get the same vector. You should be though. So be careful with your negative sign, and I'll see you guys later. Bye.